Hey everybody, welcome back to a new video. Today we are going to be checking out the Anker SOLIX F3800. If you're looking for an unbiased, honest, in-depth review of this power station, you've clicked on the right video. Now, one of the most exciting features about this power station is the ability to get 240 volt split phase power out of one single unit. That means out of one unit you can power well pumps, you can power large air compressors or welders. You have the ability to feed your main panel through an interlock or even connect up to a 240 volt transfer switch for home backup power. Now, the form factor for the F3800 is a little bit different than other power stations we've seen. It's more of a tall, narrow design so it can fit into tight places. Now, it does have 4 different wheels and you can move it around. I also like that there is a built-in handle so you can pull that up and then you kind of just tilt it back like a dolly and you can move it around this way. This power station is fairly heavy. It comes in at 130 pounds because of its large LFP battery. The internal battery is rated at 3,840 watt hours of capacity, and you have a massive inverter that's rated at 6,000 watts. Now, breaking down some of the additional features of the F3800, this does take expansion batteries. For example, each main head unit can take up to 26 kilowatt hours of capacity. I only have one connected right now, so this has a total capacity right now of 7,680 watt hours, which is massive. Speaking of the connection cable between the battery and the main unit, this is fairly flexible, so with a small twist in it, it does sit pretty tight against the side of the power station. The F3800 does have UPS functionality with a cutover time of 20 milliseconds. We'll be testing that. This also has fast AC input and adjustable charging via this smart app, so you can actually adjust that charging speed. Finally, this can take up to 2,400 watts of solar panel input, and we'll definitely be testing that later in the video. Now, I'm really excited for the next portion of the video where I show the true performance of the Anker F3800. How long does this last as a home backup solution? We'll be testing that. What quality of power do we get from the AC inverter? I'll be testing the DC output and USB ports. What about 240 volt? Can you get 240 volt output at the same time as AC charging? We'll go through a bunch of different charging demos like testing solar panels. After all these tests are completed, you'll know exactly how this power station performs. Since the Anker 3800 is designed to be a home backup system, one of the most useful tests I could demonstrate would be running critical loads during an extended power outage. During this simulated power outage, I had the F3800 connected to my 240 volt transfer switch. I decided to run 5 of my most important circuits, and here's a breakdown of the appliances I was running. My kitchen fridge and microwave were connected, my basement fridge, my home office so I could keep working as the power was out, my Google Fiber box and internet router. I also had my garage door opener and garage lights connected in. During this test, I saw an average of 300 to 600 watts being used, with the occasional jump in wattage as larger appliances were turned on. So how long did the F3800 run during this test? Well, it ran for a little over 12 hours. I did not have any charging sources or expansion batteries connected during this test, so by adding solar panels, you could extend the runtime significantly. Now, what quality power do we see from the F3800 inverter? I started my first load test on the inverter by setting up a 6,000 watt load using only the 120 volt sockets. After 2 minutes, the inverter unexpectedly shut down from being overloaded. I rechecked the user manual and noticed that the 120 volt outlets support up to 4,800 watts continuous, not the 6,000 watt load I was attempting to run. I then connected a power station to my 240 volt transfer switch in order to get the full 6,000 watts continuous. I was running 3,000 watts from the 120 volt outlets and an additional 3,000 watts from the 240 volt outlets. After the test had been going for a couple of minutes, I checked the output with my oscilloscope. It was putting out a really clean sine wave at 60 Hertz and 121 volts output. After a few minutes had passed, the power station fans were running at full speed. I measured 54 to 55 decibels of noise with my sound meter at 3 feet away. Now, did the fans move enough air to keep the internal components from overheating? When using my thermal camera, I measured 112 degrees Fahrenheit near the fan exhaust port, so the fans do really work well to keep the internal temperature down. After I finished those measurements, my stopwatch hit the 15-minute mark and the F3800 passed the max load test. How many watts will the inverter allow you to pull before it shuts down from being overloaded? I turned up the load from our previous test to a little over 6,000 watts, and after about 1 minute, the power station shut off the inverter and displayed an overloaded error message on the screen. Now, how does the inverter handle large inductive or surge loads? In this test, I connected my miter saw, air compressor, circular saw, and hammer drill all into the 120 volt outlets. My brother and I started all the tools at the same time, and the inverter handled the surge load without an issue. I wish the display would have showed the true surge wattage, but I'd say that that's super impressive to handle the surge current of all those tools at once. The SOLIX F3800 is also advertised to have a 20 millisecond UPS cutover time, and I'd like to test that in the next section of the video. Now, one important thing to note about UPS mode, whenever you're charging from AC input or in UPS mode, only these three outlets are active. For example, the 240 volt output is disabled, and same with these three outlets over here. In order to test out the UPS mode, I have my desktop workstation, LED monitor, and studio lights all connected into the power station, and I'm running a stress test on the computer to simulate a load. I also have my oscilloscope connected to the AC inverter monitoring the output, and as we unplug it from the wall, I hope to measure the actual cutover time. 3, 2, 1, record, cutover. Okay guys, so check it out. This flat line right here is the cutover time. So we had power coming in before, then no power, and then power resuming. So if we measured the distance between these 2 points, it gives us the cutover time, and that is 13.5 milliseconds. Now the desktop computer, monitor, and lights all worked during the cutover time, and this definitely performs better than advertised. Remember, it's advertised to have a 20 millisecond cutover time, and we measured 13.5. Now most sensitive electronics are going to do really well at this speed. If you get up closer to the 20 millisecond mark, you can have some devices cut out. Now let's go ahead and simulate a few more power outages. 3, 2, 1. You can see we had a slight flicker in the lights, but the computer and monitor are still running. 3, 2, 1. Final UPS test. 3, 2, 1. Looks good. Everything's still running. Does the F3800 have an open or bonded ground? If you turn the AC inverter on with one press, the AC inverter has an open ground. This is the case for both the 120 volt and the 240 volt outlets. However, this unit has a special feature that if you double press the inverter button, it actually bonds the ground and the neutral on the 240 volt outlets. So you can charge an electric car or power other loads that require a bonded connection. Looking at the display and seeing the car emblem will let you know that the unit is bonded. That's a really cool feature I haven't seen on any other power station. Does the power station inverter create any interference or noise when enabled? This test is helpful for people wanting to run sensitive audio equipment. Using my dirty electricity meter, the electromagnetic interference reading was measuring around 1500 millivolts of noise. I also tested with my guitar amp plugged into the inverter to see if the output would be affected. I also wanted to test what type of interference I would hear on a small handheld AM radio. With the AC inverter running, these were the results of the test.
In the slam dunk, that never happens anymore. So Jalen Brown, Jacob Toppin, Mac McClung, last year's winner, and my guy, Jaime Jaquez Jr.
Because of the small radio interference, I'd recommend keeping your equipment at least a couple of feet away from the power station. How much usable capacity should you expect while using the F3800 inverter? The internal LFP battery is rated for 3,840 watt hours of capacity. When draining the power station down until it shut off, I was able to measure 3,310 watt hours of capacity. This result of 3,310 watt hours is 86.1% of the advertised capacity and a great result, hitting our goal of at least 85%. This power station also supports multiple expansion batteries from Anker. I connected up one expansion battery to the main unit for a total capacity of 7,680 watt hours. Doing a second capacity test, I measured 6,670 watt hours of usable capacity, or 86.8% of the advertised capacity. So the efficiency gets slightly better with additional batteries connected. Next, how much power is used as the AC inverter is enabled sitting idle? I started with the power station at 100% state of charge and left the inverter enabled for 12 hours with no load connected. When I came back, it was sitting at 77% state of charge, meaning the inverter had used 23% of the battery over a 12-hour period, or about 1.91% per hour. This higher power usage is due to the large inverter and smaller battery combination. You'll need to plan accordingly when running loads for a long period of time, since the inverter is quite a power hog. Wow guys, impressive results while testing the AC inverter. We were able to pull the full 6,000 watts for 15 minutes without any issues. Now, of course, I had that little quirk in the beginning where I tried to pull it from just the 120 volt output, but the user manual states, you get 2,400 watts per vertical section here. So if you want to get the full 6,000, you have to use either the 240 volt output ports on their own or a combination of the two. Now for the efficiency results, we got 86% of the advertised capacity on both the main unit and with an expansion battery, so that's good there. The UPS testing went really well, very fast cutover times, Also, the power that you get from this unit, 121 volts, output 60 hertz, very, very clean sine waves. So overall, very impressive results. The fan noise, it's nice that this has large fans that move at very slow RPMs. Under most loads, you don't hear the fans very much at all. When you're pushing 6,000 watts out of the inverter, the fans do turn on, but they're not that loud. Now, there was one little quirk in UPS mode where it turns off the 240 volt, and this section here, we'll have to do more testing later in the video under the charging section. So if you want to learn about that, check out the later section in the video that's based on charging options. Let's go ahead and jump into testing the DC output now, the 12 volt socket and USB ports. I want to see how much power we can get from those and how efficient they are. What voltage do you get from the DC output? I confirmed the DC output of the Anker F3800 is regulated at 13.3 volts. How much wattage can you pull from the 12 volt cigarette port? While connecting my load tester, I was able to pull a maximum of 142 watts before it shut down from being overloaded. Since there's only one DC port, you'll need to purchase a 12 volt cigarette splitter to run two separate loads at the same time. Just make sure you don't pull over a total of 142 watts. How much usable capacity can we pull from the DC output as we discharge the power station? The F3800 is advertised to have 3,840 watt hours of capacity. While draining the power station completely down via my battery load tester, I was able to pull a total of 3,367 watt hours over a 26-hour test. These results were 87.6% of the advertised capacity, which is above my goal of at least 85%. This is fairly rare on a large power station, so thumbs up to Anker. How much power is used while the DC output is sitting idle with no load? I started the test at 100% state of charge on the power station, and checking in 12 hours later, it was at 99% state of charge, meaning the DC output is very efficient and only uses 0.08% per hour while sitting enabled with no load. How do the USB ports perform? The F3800 has 3 USB-C 100 watt power delivery ports and 2 USB-A quick charge ports. Testing out the USB-C ports first, I plugged in 3 different loads: my HP ZBook laptop, my River 2 Pro, and my Energizer 320. My laptop charged around 60 watts when connected, the EcoFlow River 2 Pro charged around 95 watts, and the Energizer 320 charged around 100 watts. With all 3 devices charging at the same time, the charging was fluctuating anywhere from 235 watts up to 250 watts. I then tested all USB ports at the same time, connecting up a variety of different devices. By this time, my laptop battery was almost full, so it was only pulling around 40 watts from the power station. Adding all the loads up, it was right around 245 watts of power being used on all the USB ports. How much power can you get from both the USB ports and the DC output combined? Testing both the USB ports and the 12 volt cigarette port at the same time, I was able to increase the total power to almost 400 watts from the power station DC output. I was curious if the DC output would shut off randomly overnight while running a load. In order to make sure that it didn't happen on the F3800, I connected my IceCo Go20 12 volt fridge into the 12 volt cigarette port and let it run over a 24-hour period. Checking in later the next day, the DC output had not shut down and the fridge was still running with the power station at 92% state of charge. Running a 12 volt fridge, CPAP, or even a small fan overnight should not be an issue. And finally, how does the DC output affect a small handheld AM radio? Here's a demo of what happens when you have a small radio next to the power station with the DC output enabled.
Jazz fans are probably going to have to accept that this is going to continue happening to some degree, and there's...
To avoid this interference, I'd recommend keeping your sensitive devices a couple feet away from the power station. So now that we've finished the DC output testing, let's break down some of the results. It is regulated at 13.3 volts. It's really nice that we are able to pull more capacity through the DC discharge than the actual AC capacity test. So very efficient DC output. Also, when you leave it on for a long period of time, it hardly uses any power. I love that you get the 300 watt USB-C ports. It's really nice to have that in case you need to charge your mobile devices quickly. The only bummer on this is the fact that you can only get 142 watts from this, and there's only one port. I would have loved to see at least 2 12 volt cigarette ports, kind of like on the Anker F2000 where you get a lot more power. But on this one, keep in mind you're limited to 142 watts. Now in the next section of the video, I want to break down all the different charging scenarios on this power station, like dual charging, pass-through charging, can it put out 240 volt while charging from AC input? Let's jump into the testing. In the next section of the video, I want to talk about the charging options for the Anker SOLIX F3800 and do some charging demos. Now the power station does come with an AC charging cable, so you can charge from a gas generator or a wall outlet. And it also comes with these 2 MC4 parallel adapters, so you can put their solar panels in parallel. Now on the left side of the power station, you have 3 different charging ports. The top left is your AC input. The owner's manual states that this will do 15 amps for up to 3 hours, which is 1800 watts. And then if you're doing a continuous charge, it drops down to 12 amps, which is 1440 watts. Below that, you have two XT60 inputs, which are for your DC or solar input. You'll notice that you have two different ranges. If you have a voltage coming in that's 11 to 32 volts, it's going to limit the amperage to 10 amps on each port. And then if you have a higher voltage input, 32 to 60 volts, it actually has a 25 amp input limit. Now, what does that actually mean when you're trying to charge the power station? Well, if you have something coming in between the 11 and 32 volt range, the maximum input per port is going to be around 320 watts. So you'll see around 640 watts total. Now, if you're going to charge at the higher input voltage range, you can get quite a bit more power. Each port supports up to 1200 watts for a total of 2400 watts DC input. Now, take note that you will have to purchase your own charging adapter if you want to charge with DC input. Now, 25 amps is a lot of power, so you will want to use 10 gauge wires. Luckily, I found two of these 10 gauge XT60 cables online on Amazon, and I purchased these so I could test the power station. Now, I first want to test AC charging input on the power station, so I've set it to the fastest charging speed. Let's go ahead and take a look at the screen. So we're getting around 1700 watts charging input right now, and it's estimating 0.9 hours until the battery is full. Now, in the Smart app, you do have the ability to adjust the AC charging speed, which is really nice. And if you want to charge at 1800 watts, it's going to take a little over 2 hours to fill up the power station. Now, while AC charging, it's very important to note that you get power from these three UPS outlets, but I've noticed that these three outlets next to those are completely disabled. And I've also tested with my voltmeter, the 240 volt output is also disabled whenever you're charging from wall power. Now, I've been sitting here thinking about this for a minute, and let me explain why this might be an issue. Now, the only way to get the full 6000 watt output is via these 240 volt connections on the top. So let's say you have this connected to a transfer switch or to an interlock powering your home during a power outage. Well, let's say solar is not available, it's cloudy or it's nighttime, so you can't charge it up via solar. The only other way to charge it up would be via an AC generator. So you connect in your AC generator, and well, guess what? The 240 volt is disabled. So now you only can get power from these three outlets. So you'd have to run extension cables to your critical loads instead of powering them via a transfer switch or an interlock. Now, here's a quick demo of what happens here. Right now, we are not AC charging, and we get 240 volt output from these outlets. Now, I've just connected the AC charging cable, and you can see that 240 volt output is disabled. We are no longer getting power from that port, even though the AC inverter light is still on. Now, one final note about AC charging. When it is charging, the fans take a minute to turn on, but they are very quiet. Here's a demo of what the fans sound like. Now we're going to go ahead and swap gears a bit. I want to test the DC input. So how much power can we get on each one of those XT60 ports? Now, I recently purchased this BK Precision high-powered DC power supply so we could simulate different battery voltages. I've set the power supply to 13.3 volts to simulate a 12-volt battery. We're getting 124 watts input. Now, this will take around 30 hours to fully charge the power station. Now, what happens at 24 volts? Adjusting the power supply to 24 volts, we're getting 225 watts input. Now, this will take around 17 hours to fully charge the power station. Now, if you remember, if you have voltage under 32 volts, it's limited to 10 amps, and that's what we're seeing here. We're getting 9.5 amps input at 24 volts. So if I turn this above 32 volts, we should see this number jump up to around 25 amps. Now, don't mind the fans in the background. That is from my DC power supply, because now I've turned it up to 36 volts. We're getting 866 watts input. We're hitting the higher amperage input limit now. So looking at the DC power supply, we're getting 36 volts at 24.6 amps. So now we are hitting the higher amperage input limit and getting much more power. Now, in order to simulate my 48 volt battery, I've set the voltage to 54 volts, and we're getting around 21 amps input. And that's around 1150 watts. Remember, each port is limited to 1200 watts, so we are really close to that actual limit. So looking at the screen, we're getting 54 volts at 21.7 amps. So pretty cool to see that much power going into the power station. Now, if you remember, this power station has dual XT60 inputs, good for 1200 watts each. Now, unfortunately, this DC power supply goes up to 1200 watts peak, so we can only max out one of those ports. But I do have an idea to try to get the full 2400 watts. Let's go ahead and try it out. So right here I have my EG4 48 volt server rack battery, and I have these 10 gauge wires coming off. We're going to use this to try to get the full 2400 watts charging input. Let's connect it up and see what happens. So I've gone ahead and plugged in both of the battery connections at the same time, and it's pretty interesting. We're actually not getting any wattage. We're getting a bunch of different relay clicks, meaning it's thinking about it, but it does not like having the same battery plugged into each of the charging ports. Let's go ahead and remove one of these. I think if we remove one, we'll start seeing it charging at the full 1150 or 1200 watts. So just after a few seconds, we're seeing 1150 watts charging input with just one of these connected. Now my guess is that it did not like the common ground shared between two connections coming from the same battery. So now I have my DC power supply and my EG4 battery. We're gonna connect both of these up at the same time to see if we can get the 2400 watts. Okay, so we're getting 2300 watts input from both the battery and the DC power supply connected at the same time. So if you have two different DC power sources, you should be able to max out the charging input. So let's go ahead and break down the power input. We're at 52.9 volts at 21.6 amps. And then on the battery, we are at 52.5 volts and 22.7 amps. Now, sometimes when you have a power station that has dual charging ports, the voltage actually has to match on each port. So to test to make sure this works, I have a 12 volt battery and my 48 volt battery both connected to the charging ports at the same time. So with the 12 volt battery and the 48 volt battery connected at the same time, we're getting 1268 watts input. So it does not seem to have an issue with different input voltages. In my next test, I want to see if the Anker F3800 supports dual charging, or AC and DC input at the same time. So I have my 48 volt server rack battery connected and the 120 volt AC charging. So let's see what's happening. So with both AC and DC charging inputs connected at the same time, unfortunately, we are only seeing AC input of about 1700 watts. So this model does not support dual charging, and it does not have a DC priority or solar priority. So if you have AC and DC connected at the same time, it will choose to charge via AC input. Now, what about pass-through charging, or the ability to charge the power station and use the outputs at the same time? Now, if you have DC input like what we have right now, you can use the DC output, you can use the USB ports, and you can use all of the 120 and 240 volt outputs. So you get full usage when you're charging via DC. Now, swapping over to AC charging, you can still use the DC output and the USB ports, but keep in mind the 240 volt ports are disabled, and same with these 320 volt outlets. The only outlets that you can use when you're AC charging are the 3 UPS outlets. So let's go ahead and do some solar testing on the Anker 3800. For the solar conditions today, it's a winter day, around 40 degrees with just a few high clouds. This is like the first day we've had sun in like 2 weeks. I'll be testing with this array right here. These are two 400 watt Taliesin solar panels. I'll be putting them in parallel because I can't go over 60 volts on the charge controller. The other array that we'll be testing with is this Renogy array that's built with 200 watt flex panels. I'll be taking 4 of them in a 2S 2P configuration to stay under 60 volts as well. So let's go ahead and test these out. So let's go ahead and do the Taliesin solar panels first. They are wired together in parallel, and I have them connected into the side of the power station. Well, it's basically impossible to see the screen in the sun, so I got a screenshot of the app that I'll throw on the screen. So we're seeing right around 309 to 310 watts input. Now, some of you may be wondering why we're only getting 310 watts from 800 watts worth of solar panels. Well, these solar panels put out peak power at 30 volts, and if you look on the side of the power station here, that is between the 11 and 32 volts, so we're seeing a 10 amp input limit. If we wanted to get higher power, we would have to have a higher voltage solar panel, but I can't put these together in series because it goes over 60 volts. So unfortunately, these Taliesin solar panels are not ideal for this power station because they're low voltage and high amperage. So let's go ahead and start testing these ones. I'll go ahead and wire these together in a 2S 2P configuration and see what we get. So now I have these 4 panels wired together in a 2S 2P configuration. I have them connected into the power station, so let's see how many watts we're getting now. Now with the Renogy array connected up, we're getting 769 watts charging input, so almost full rated power from those 4 200 watt solar panels. Now there are a few things to consider if you're building a solar array for the F3800. The first thing is you want to make sure that your solar panels do not go over 60 volts VOC because that is the limit on each one of these charge controllers. Now that's not ideal. It is kind of a bummer since you can't put, panels in series to reduce your amperage because they've opted to go with a high amperage, low voltage input. So you do have to plan for larger wires and fuses and such. So basically, in order to get the full peak power on this, you want to make sure your voltage peak power is between 32 volts and 60 volts so you can get the full 25 amps. Now we were able to get pretty good numbers from the Renogy array with the panels in a 2S 2P configuration. We almost saw 800 watts there, Now, if I had 6 of those panels, I think I could have gotten really close to the full 1200 watts input. So it is possible to max out each one of these charge controllers. You just have to wire your panels differently than some of the other power stations you've seen on the channel. Now, what about having solar panels connected 24/7? I did test this for solar panels overnight, and in the morning when the sun was coming up, I did not hear any clicking or beeping noises on the power station. It just started to charge whenever the sun came up and sun was actually on the panel. So no issues having this connected to solar 24/7. Now, unfortunately, when we were testing the charging options on the Anker F3800, we did find a few quirks. The first quirk was that whenever you're AC charging the power station or in UPS mode, they're basically the same thing, it would disable the 240 volt output, and it would also reduce half of the 120 volt outlets that you could use. So keep in mind, whenever you're AC charging the power station, you do get a loss of functionality on the AC inverter. It's like it almost doesn't support full pass-through charging because you don't get the 240 volt output. A way around that would be to use solar panels to charge, because you do get full functionality whenever you're charging via DC input. For example, with solar panels in, you do get the full 240 volt outputs, and you also get the 120 volt outlets. So keep in mind that you don't have any issues when you are DC charging. It's only when you're AC charging. The other quirk that we found was that whenever I was testing dual charging input with AC and DC at the same time, it didn't accept dual charging. It only accepted AC input. So there's no priority to solar input whenever you're charging with 2 power sources. Well, now that I've completed all the testing on this power station, let's break down a few things like pricing, warranty, and customer support. So how much does this unit actually cost? Well, it's currently on sale on Anker's website for $3,500 for this unit here, which is around 91 cents per watt hour. If you want to purchase the unit and an expansion battery, you do get quite a discount on the expansion battery. For example, it's $5,000 right now, which is around 65 cents per watt hour. So the prices are pretty decent for a company that's well known and established with good customer support and warranty. Speaking of the warranty, you do get a full 5-year warranty on this product, and you do have Anker's customer support that backs that up. Now, one thing that sets me apart from other YouTube channels that review these power stations is that I have a full-fledged grading system. So each power station I test, I take all the performance numbers and I put them through my power station grading system. I give it a score of 1 to 10 so we can really find out which performs the best. Now, I have all that information compiled on my website in my power station grading sheet. I'll include a link to that down in the video description, but let's go ahead and see how the Anker SOLIX F3800 did in the system. Now, here's a brief overview of the power station grading system 2.0. This is the upgraded latest version. So if you look at the list here, there's 20 requirements that a power station needs to meet in order to get a perfect score. So let's go ahead and bring up the results for the Anker SOLIX F3800. So taking a look at the score here, we got 8.5 out of 10 points available, or a B grade, which is definitely a solid score. It lost points in 3 different categories, so let's break that down. The price per watt hour was 91 cents for this power station, and that is above 80 cents. We lost a half point there. It does not support dual charging, meaning charging with AC and DC input at the same time, so it lost a half point there. And also, it did not support 150 watts DC output, so it lost a half point there. Now, earlier in the video, I mentioned that pass-through charging was definitely a question here, but let me explain why I gave it a point. Basically, it supports full pass-through charging with DC input. It also supports 120 input and 120 output, but it does not support the 120 input with the 240 output. So, being that it does support 2 out of 3 of the scenarios there, I still gave it a point. Now that we finished the performance testing on the Anker F3800, you guys will have to let me know what you think about its performance. If you own one, did you learn anything new? What do you guys think about all the tests that I did? Make sure you throw a comment down below and let Anker know, give them some feedback, what you love, what you don't like about the power station, how they can change it, or what you think they should keep the same. If they're gonna make this again, I'd love to get those comments down below so they can read the feedback about this product. Now, overall, we got really good performance from the AC inverter. When you're looking at my opinion of pros and cons, there's definitely more pros to this unit than cons. But let's go through a couple different ideas of what I like and dislike about the power station. Now, remember, this is just my opinion. I already gave you guys all the performance numbers, so now it's just my opinion, kind of what I think about it with my particular use case. Every single person is going to use a power station differently. Sometimes they're going to charge with AC input only. Sometimes they're going to charge with solar only. So it kind of just depends on how you use the power station. So this opinion may not even apply to what you guys think. So going through the cons, I think the biggest con is the fact that whenever you're AC charging this, it disables the 240 volt output. Not ideal when you want to get the 240 volt output and charge at the same time. The second con is the fact that this just doesn't come with any solar adapters or DC charging cables. One of the most common questions I get is, hey, how do I get this adapter to work with this? And you know, that's the case on this power station. You're gonna have a lot of people like, what do I do? What adapter do I purchase on this? And the last con is the fact that this has the 60 volt cutoff. Now that might not be an issue for everyone, but in my case, every single solar array that I have in my yard goes over 60 volts. So I always have to reconfigure them whenever I'm gonna charge with solar on this power station. So that's a con for me. Now what about the pros or the good things about the power station? The first thing is I love the form factor. This taller, skinny design is really cool. And the fact that this is really flexible, this cable here doesn't take up much space. I love the fact that the fans are fairly quiet. If you aren't pulling 6,000 watts from this unit, the fans are really quiet. They're also very quiet whenever you're charging the power station, so just keep that in mind. I love that this has such clean power output, very clean sine wave. Also the fact that it has 240 and 120 built into one unit. It's just more affordable that way. A lot of other power station companies make you purchase 2 units and put them together with special adapters to get the full 240 volt split phase output, so you don't have to do that with this unit here. So lots of good things about this power station. Let me know what you guys think about it down in the comment section. Now if you guys like this video, please smash the thumbs up button. Also, I'll recommend a few other videos that you can check out if you're interested in content like this. I really appreciate you guys watching to the end of the video. Share the video with your friends, share it with your family. Thanks for watching. We'll see you guys in the next one.